Hello. Oh, Nick, you're on mute if you're talking
That's
to
right.
us.
I was. Who is this Firefly's AI note taker? Maybe Laura will know. Hey, Andrew.
Good morning, Nick. Good morning, everybody. Just lurking here.
Laura, are you there?
Yeah, I'm here. Are you
Hi.
there?
I am. Who's this Firefly's AI note taker, and why are they note taking our business?
You know, peeps were freaked about that last time, but that has been in like all the SIG meetings for a while, but I think it just recently started. I don't know. Yeah. I don't actually know the admin background on that, but I do know that it like has been in a lot of SIG meetings for a while.
Where does the output of the note taker get pushed?
You're still asking questions that I don't know the answer to.
Okay.
Yeah. It's a great question.
As a point of reference, maybe I think other SIGs are just kicking those out of the meeting.
Oh, I see. Okay. Well, we should do something about it, I guess.
Rebel.
I know Steven isn't going to make it today, but I think Jeremy is. But if not, I can take control.
Take over.
Yeah, okay. I have to leave and come back. I'll be right back.
Revolution. Do we have new people? SKMJ? Sorry if you joined other other names before. Maybe I just didn't see it. Welcome.
So this bot is not, it needs to be kicked out, according to other people asking questions in the Kubernetes Slack. I don't think I can do that. I guess I'll wait for Laura to come back.
Laura's coming back with the powers. Here you go.
Can I? Yeah. Hey, Laura. So I did a little digging on Slack. It looks like the advice from the CNCF is to kick the Firefly's AI note taker out of all meetings.
She's not back yet.
Okay.
Oh, sorry. I thought I was not on mute. I was saying, okay, now that I joined as like the SIG the official meeting, I could like deny it, like ask me to deny that specifically when it came in. So anyways,
Cool.
seems to be, it doesn't seem like I have to do another kick, just that one. It seems once I deny it recording privileges, it just doesn't want to be here anymore. Okay. Let me get slightly organized, but then we can get started. Let me get the agenda really quick too before. Okay. Okay, hello everybody. Welcome to Kubernetes SIG Multicluster meeting for Tuesday, April 22nd, 2025. My name is Laura, and apparently I am your host today. On behalf of Jeremy and Stephen, our co-chairs. Looking at the agenda, indeed it is I who am first, so I'll go ahead and go. Though I am ultimately here to share something that really Nick and Corentin worked on the most, as well as like the rest of Nick and Corentin's team. So feel free to like jump in at any point, obviously. In fact, I'm even going to show you a video that Nick himself, I'm going to kind of scrub through it and talk through it, but this is like literally a video that Nick made and has Nick in it. So yeah, feel free to jump in at any point, but I wanted to share this here. For those of you who weren't at KubeCon EU or didn't catch up with some of the back chatter from that, one of the projects that folks from GKE were sharing related to multi-cluster is something called Multi-Cluster Orchestra, which is this MCO that we're talking about in this demo, which is an open source implementation of something that's capable of taking preferences from a user regarding workload placement across clusters and then making just-in-time decisions about routing workloads to other clusters in that priority list. A like really key use case of this is if you are chasing like a certain type of hardware capacity that maybe like there's a stock out for in a specific region. People run into this problem on a lot of cloud providers. Then this tool is capable of, if that has happened to you and node auto scaling hasn't solved your problem, and like we just need to back out of this region altogether and like go somewhere else to get the type of node that we need, then this is capable of detecting that, following a set of user preferences on how to do that. And then there's in this case, there's a plugin connection with Argo CD, or you could use some other CD tool to actually effectuate that workload placement there. After MCO has made the recommendation and basically informed whatever your CD tool where your thing should go. One of the cool things that's fun for SIG-MC is that this is A, open source, B, built on a cluster profile project that many people here have been working on as well. So the inventory, the capability of being able to know like what clusters are even available or possible to balance this workload across your fleet, that is drawn from the cluster profile API. And to kind of briefly, I don't know if this is the best, but I don't want to get too confusing with the captions, but you can see here that there's a situation where there's a number of clusters, including one at the bottom of this list that says MCO Hub. So MCO Hub is, this is deployed in the format where there's a hub cluster, which has also been talked about in the context of the SIG as well in the past, as this is the cluster that has kind of like the oversight privileges over the rest of the clusters in the cluster set. And then there's these other effectively workload clusters that all have these different MCO cluster names that are in different regions. I'm going to scrub a little bit to here to kind of emphasize. You can see that these are some calls to the cluster profile API in that hub cluster to how to say, kind of showcase that this intersection with you can see like this API version multi-cluster x case.io. This is the cluster profile that we've been talking about in this SIG for a while, just to indicate that that's something that this hub cluster has, this is where this information is for this hub cluster. And then doodly doodly do. I'm going to skip over a little bit of this. Sorry, Nick, to get to the part that is right here, which is about this orchestra kind multi-Kubernetes cluster placement, which is actually the interface both in which a user can specify what their preferences are for how new clusters should be targeted in what order, and also the means by which the recommendation for which cluster should be like the next actual target in like a given real-time scenario is actually going to be reported as a status. So I'm going to go fake scroll like this and just show you being highlighted here on line 50 is this rules portion of the spec that is the place where, as mentioned before, the user can specify for what kind of like fallback order things should go in. And then at the very bottom in line 61 in the status stanza, this is where that information about like where should we actually be putting some, where should we be doing some workload placements right now, given the conditions right now and the situation right now. So this is where that information is. And sorry, skipping this hilarious part, Nick. Amazing jokes, of course. And then there's going to be an example in here that's going to show this workload that is initially present in this one cluster hit a stock out. It's simulated in this case so that the demo could show it by having like a certain pod limit on the cluster. But once some extra load, which is also simulated by Nick on the initial cluster, after some time, that's going to try and scale up locally in that initial cluster. Eventually it's going to run out of space there, either because of a real stockout or in this demo case like a pseudo stockout that we've simulated. And then if for a while you watch this multi-Kubernetes cluster placement kind, that again was where that status stanza was that told us where to actually place stuff. It starts out just with the recommendation that we had at the very beginning, but after some time, there it is. It will then recommend, once it's observed that it can no longer meet the load in the single region, in the single cluster, that it needs to back out and make a workload deployment on a cluster that is next in line of the region preferences. In this case, again, as mentioned before, this is integrated with Argo CD. There's a plugin to watch that orchestra object so that it can actually make the deployment on the new which I kind of like skipped somewhere in here, is the screen to see that, but you can see the effect in the GKE, the Argo CD screen to see that, but you can see the effect in the GKE, the GCP console, that this deployment of the same name is now also deployed in this other cluster that's in location US East to meet the criteria of the placement suggestion. And then there's some more in here too. It will scale down when the load decreases. MCO is also capable of defragging the situation. So once the load is removed, then after some time, both the HPA and MCO are going to react to that situation, and it will eventually equilibrize to, is that a real word, to the situation where we're back to just having our initial deployment on the US West cluster because that's the highest priority. So I'm kind of scrubbing through. It's really fun watching this video where Nick is like, any second now. But yeah, you can see here eventually it goes down to no longer being present in both of those clusters. Okay, that's what I wanted to share to kind of give people some vision of what was going on, and at least at this point, what its intersection is with cluster profile in particular. I heard like some chat noises or whatever. And I also see a hand, but before I do that, Nick or Corentin, is there anything you want to say before?
Let's go through the questions, and then I'm happy to jump and give some flavor also on some of the approach we're taking here.
Okay.
Actually, before we get to the question,
Yeah.
just before we get to the questions, because I could see kind of a theme in a lot of them. Like right now, the intent is to get this into SIG Multicluster, right? And we have to do work to get it there. So questions like, is it feasible to demo this using kind? In its current state, no, but we're not like really far away from that. In fact, our goal is to be able to do that in the next, inside of the next month or so. So the idea here is to take any sort of Google specific things out of it. We needed a way to kind of move forward up until now, but it will be demoable with kind very shortly. Sorry.
Okay.
Like, sorry, last thing, because I'm a bit of a babbler, and I apologize.
Yeah,
but bringing this up here is to figure out, the idea is to figure out how we can make it usable by other providers. So what does the provider model look like for MCO? Like, where are the places you need to plug in? We have good ideas, I think, but better to get them, with all of you as opposed to just making assumptions.
Okay, so that's John's question in the chat. There's another question from Mike. How is capacity back pressure being communicated to multi-cluster control plane? Corentin, you want to talk about that?
Sure. One of the approach we've taken is to leverage metrics. We're assuming the clusters have a Prometheus endpoint, so we're doing PromQL, and we're actually querying something we've called like enable to scale out. So when a cluster is unable to get more pods, it's got unscheduled pods, and the cluster or scaler is saying like, yet, that's when we get that signal from the cluster directly as a metric and react to it. So that's actually one of the fundamental thing we wanted to do, is leverage metrics instead of trying to bake everything cluster profile. This is something I talked to Ryan quite a bit, because he's been talking about properties, and I'm like, well, we can't fit everything in properties, so we need to look at metrics here. And so that's, I think, one of the next thing we need to get in cluster
rapidly, potentially. So not wanting to go through the cycle of like updating that CRD many times in rapid succession as a controller for performance.
Yes. Also, that way you can get granularity at the workload level, because cluster profile will have properties for the whole cluster. So as soon as you get to a workload level thing, it's all bets are off, right? And because we're also talking about a scheduler, so when you think about number of CPU and memory, you will need to know exactly the topology, how it's breakdown and all that, how the scheduler locally is going to behave and all that. And we're like, okay, no, we don't want to replace what the scheduler does locally. It's going to do things. What we can do, though, is get a signal from that scheduler saying, hey, I cannot do my job. And then we can react to that, be like, okay, the scheduler here told us it pretty much cannot scale more. It's stuck. Let's go get another cluster. So that's one of the property we're approaching. The way we're approaching this problem is being reactive. And I think that works well, and that could be expanded to a lot of things. And property metrics is becoming, I think, one of the main thing here.
And just for clarification, sorry.
No, keep following up. It's fine.
Just for a point of clarification, are you expecting the metrics to be standardized, or is that an implementation detail that should be opaque?
I expect it to be customizable. So I would want someone to be able to bring their own metrics. I mean, every workload is gonna want to have its own metric on what it means not to be able to scale. There might be some very specific things. Health could also be a metric and be very specific. Also, right now we've baked a lot of assumptions in the binary. Like, if you look at the query for the metrics, it's actually quite complicated right now, and that's something we want to simplify. It's a PromQL that's long like this, and it relies on the log metric and a lot. It's not very great today because it's a complicated PromQL, but I think the important aspect is metrics. If you can plug a metric, you can provide us a metric. I mean, anyone can write a metric. It should be simple enough. A workload can come up with their own metric, be able to read that metric from the scheduler and leverage that metric for auto scaling and scheduling. And while I'll jump to more questions afterwards. I wanted to talk a little bit about some of the principles. So metric is one of the principles, leveraging metric instead of trying to bake everything into cluster profile. That was one big thing. One of the second thing is we want to schedule all clusters at the same time. So we have that placement CR, right? We're going to output all the clusters at the same time. It's like we're going to tell you like all the list of all the clusters in that status. What that gives us is the ability to have like a global view of where a workload is going to go. This is different if you're familiar with the Kubernetes scheduler, when you get a pod goes on a node and scheduler does pod to node, pod to node, pod to node. So we try to go like the whole thing. That gives us a bird's eye view, which is pretty nice, makes a lot of things easier. So that's another thing. 3, we've isolated the scheduler. Laura mentioned it with plugging Argo CD. It's pluggable. You can get any CD you want. You could get ultimately the work API. We're developing a small one as well, just for showing. There's a bunch of things you can do there, but we want to focus on the scheduler. So that's another thing. And I'll show, I think, in the next topic that Bobby's bringing, I put a picture in there, kind of isolating things. And we baked in auto scaling. I think we kind of, because we want to do that bird's eye view and reaction, we want to get auto scaling kind of in that mix of figuring out where workload goes. So we want to get auto scaling kind of integrated in the scheduler for that decision process of more clusters and where and all that kind of tied together. So that's been one of the design decisions for this thing. So, yep, that's some of the principles. Was there other questions? If you guys want to jump in, please. I see share demo link in the chat. I think someone will post that.
I also will say MJ had a hand and then Un had a hand. MJ, was your question answered or did you give up?
No, so it was more like Q when it does a scheduling. It usually does this fire to multiple clusters, and the first one which sticks gets accepted workload. And that basically because of the like unique hardware requirements, like multiple GPUs, certain architectures. How in this case scenario, like I'm afraid of the scenarios where you have very big scale up or requirement, and you now ended up fallbacking to 3 or 5 clusters in a row because none of them can meet the capacity. Is there any ideas how we can solve something like this?
Yeah, I think, yeah, the approaches are a little different. I think MultiQ has been looking at mostly like static demands, right? You ask for a static thing and you like, you know, like, oh, I want that training job of 100 pods, and then it tries to find a spot for you, right? We've been taking the approach of auto scaling right now. So where you would start from 0, like start from 1 and let it grow kind of aspect. So more of an inference as opposed to training. So that's where you wouldn't have that problem normally as much, right? That queue solving with that commit and try to find capacity this way. And also in terms of prioritizing cluster when we schedule, we definitely want to get some signal of capacity. Be like, hey, there should be some instances that satisfy this. In GKE, we have like something that for our cluster of scalar, we're trying to add more signals right now that would tell you, I would be able to get instances or I would not. And the cluster of scalar should be able to tell us how much kind of capacity it sees, how much, what do you go, like overhead it could have, or no, headspace it would have in front of it, right? So you could get that signal and factor that in to pick the next cluster where you would auto scale to.
Right. And
it's not perfect. Yeah, they're competing schedulers at the end of the day. Yes.
Is it right to assume that basically this needs to be application topology aware too? Like you're moving all application as a bulk, meaning you can't just stay like half of the applications out. Like cross-cluster networking communication is out of scope, I imagine.
So the interesting thing here, just to be extra explicit, like this is just making recommendations to a CD tool. So how you want to define what that application is, and in the case of Argo CD, it's the repo that's being synced when you create the application. that would define what actual configuration gets deployed into the clusters. So if you have a strong coupling between two services, like you need front end with back end or something like that, you might want to sync them together. But I actually think a legitimate request that I've actually heard from a customer was, hey, we need some affinity. We do think that we would probably want to separate front end and back end into different placements, but we want to make sure that they get placed together. So like that's heard, don't have an answer for it.
Cool, thanks.
And multi-cluster networking is definitely something that'll be addressed. The expectation is that an application would span across multiple clusters, right? I think we've been all talking about multi-clusters. If you look at Federation, it distributes a bunch of replicas in a bunch of places. In that sense, it's similar, where a workload would have chunks of itself in multiple locations. I don't think we're trying to keep workloads, a singleton, like even if it's got multiple pods, but on the single cluster. I think we want to get to that point where it's distributed across clusters, and MCS is a testament to that. MCS is the load balancer effect, or a standard for load balancing across multiple clusters, right? So,
no, it's this is great, like to move towards. I know that Google might not have this problem with like global nets and network spans across the regions, but if you start thinking about how do I bring this to on-premise or my own data centers, how do I plug the networking things into
networking
that?
is hard. Not gonna lie to you.
Yeah.
It is a hard thing, and networking definitely hard. As soon as you move to stateful, then you have the volumes also to deal with. This is everything multi-cluster is doing, and because we get out of the cluster, we get out of potentially the region where you're at, and we don't know where the other cluster is going to be. We potentially would have to move things. That's why multi-cluster is so hard. I think we're slowly chopping there and there. MCS being an example of that, the scheduler being an example of that, syncers we have being an example of that. There's a lot of that. Mike?
Yeah, I'll just say, there's lots of work on networking, multi-cluster networking in the world, right? You shouldn't have to duplicate or, pick and choose, right? You should just be able to play nice out of the box with whatever solution someone wants to be using.
Exactly that.
It reminds me of, and it takes me back to the thing when Kubernetes first came about. People said that it makes a lot of demands of the network because we expect to be able to get pod IPs that are routable and things like that. And I wonder if this is kind of the evolution of that. And we do have other projects in the space, as you just said, Mike, that are kind of trying to fill that role too. So it makes sense to me. And yeah.
John, go for it, and we can reply to that too.
Yeah, so we have the same thing where we might want to transport our applications across clouds or across clouds and on-premise, and you run into the networking problems. Right now, we're trying to cheat around a little bit by using Istio, and then everything below that is someone else's problem, and that does work. But yeah, one of the issues is, like with MCO, where we might want to have an application expand beyond the limits of what a current network configuration allows. And then you could technically say, well, then you just add more IP space or add more something or other. But the add more in the networking world is very difficult. Usually you can't get the CIDR range that you want, or you can't expand it. So that's why one of the, it's also why I had this somewhat crazy idea in the chat, where you dynamically provision additional cluster capacity to solve your network problem, even though you should probably solve your network problem.
Let me just, before I head off to Ryan, this auto provisioning of cluster is definitely something we have in mind as well. If you look in the SIG's agenda, I think that's the next point. Bobby mentions it. We're together with Bobby, and you could imagine that if the scheduler is saying, "Oh, we should get this workload to another cluster," but that cluster, there's no cluster available, some cluster auto provisioning could come in and provision the cluster the same way the node auto provisioner works.
So just to be the stickler PM on the call, That sounds awesome. It was the first thing I thought of when we were building this. And also almost every customer that I've talked to said they don't need it because they pre-provision their clusters and they don't really want us adding clusters on the fly. So while it's cool and we may do it, there's not a whole slew of demand. There's not customers that necessarily want us to just stamp out clusters for them right now, is at least what I've heard.
And
No,
it's
I can
also
imagine
harder
that.
than it sounds.
Yeah, and
Sorry.
I can imagine it's also kind of a niche concept to solve this. Because the reason why we're doing it, we're in GCP, Azure, and AWS, and you can never really get a unified network anywhere. So we figured we use the lowest common denominator, but as a downside, it means that now you have sizing problems. So that's why we prefer to just use, in our case, Argo to target multiple clusters. But of course, Argo right now is not MCO aware. So if you want, say, 500 replicas, it's going to be in one cluster, or 500 for each. So you have 1500 replicas. So it's not aware enough right now to do that. But if it would have that awareness, and then the next step would be, adding more clusters on the fly. But that is something that would probably be both out of scope and relatively easy to engineer on the side.
Let me make a comment on the number of replicas here. One thing we want to do with the scheduling is we've been trying to schedule clusters and explicitly not touch the number of replicas. And I know that federation touches the number of replicas, especially the kind of like slice and dice, right? And say this clusters get so many and all that. We've been trying to avoid that, to leave it to like HPAs and cluster scalers kind of to grow. But this is something I think we've been hearing also. Interestingly, from a lot of workloads are very static, or a lot of clusters are very static, and there may be some room for a little bit of that slice and dice. But fundamentally, I want the schedule to focus on clusters more than I wanted to focus on pods. The other comment I wanted to react to is like from James, like when he's saying like that's that new paradigm. Yeah, 100%. I mean, we've had Kubernetes go node to clusters, and now you're doing an interaction at the cluster level. We want to go cluster to multi-cluster kind of global view where you define your workload centrally and it kind of flows in the right place, and you know, and that's why there's a bunch of blocks we need to provide to get to that vision. Federation in the past may have been the closest to that, but there's some other problems with it potentially in standard. So we want to take that approach of building blocks. Scheduling is one big of them. We've been targeting that and can go, but this is the same, like extra layering, doing more abstractions. And it's possible that we'll have to code application kind of like to have that in mind. Okay, we're distributed system, you have multiple pods, but also distributed region, you have to be aware of that distribution setting as well. So maybe that'll be something that will come more and more common. And Ryan, I can pass it up to you.
Yeah, and maybe this can be sort of the last comment so we can move on to the rest of the agenda. Thanks.
So just want to clarify a few things. One is from the API, because just like I took a glimpse at that API in the demo. It has the scale part has three things. One is like deployment name, HPA, and I forget the third one.
Namespace, I think. There's like namespace, HPA name, deployment name, something like that.
So it has a deployment name. So does that mean it only works on deployment?
No, I mean, well, we had to get the example working, but the idea is we needed to know the workload details to be able to query the right metric. It was really like how to build a metric aspect, and I think workload detail will be more of a like labels of the workload. We'll have to figure that out, but we need something that works with the metrics as well. So yeah, is definitely not perfect there for sure. Because like the way we query the metric is like deployment name is the prefix for the pods to find unschedulable pods for the workload. The HPA name is to figure out when the HPA is maxed out or named out. And the namespace obviously is to find the workload, which we could assume from the placement. But,
I see. Now I know why it's called deployment. Then the next question is, so can if user a lot of use cases that we heard was actually not about capacity. Capacity, yes, but also there are cases they just want to deploy the same application on multiple clusters just for HA purpose, not for capacity purpose. How can we do that in this API?
Yeah, you just set the minimum clusters to 2.
I see.
The HA, assuming that the first 2 clusters on that list are capable of running the deployment.
I see. And then if some of them cannot scale, then you move to a third one, something like that.
Correct. Yeah, and also, again, I don't want to say again, but the making the metrics composable or allowing people to bring your own metrics opens up a lot of other scenarios in capacity chasing. Another one I've been working on with the customer is DR. So if the metric were to say a bool that says okay DR event, and then add the second cluster, that's another sort of use case we've been fleshing out. So I think the metrics section will be really important to opening it up to more than just, working through a list of clusters and chasing capacity.
And then last question I don't fully get is from this API, I don't know how to, because the application doesn't just compose of just one deployment or some workload. There has, all kinds of secrets, config map, role binding, a whole bunch of them. How do users specify those here from this API?
What you're talking about, I think, is the package or the bundle of resources, right? This is where it's Syncer dependent. So it's, in this case, it's Argo CD, so that would live in the Git repo, and Argo would pick it up and do that. Here, what you're seeing here, the placement is only the scheduling part. This is a scheduler and autoscaler integrated, right? As far as taking objects and putting them in a cluster and like grouping them together, putting them in a cluster, potentially doing templating per cluster and making sure they're reconciled in the cluster, if they deviate, drift detection and all that, progressive rollouts, this is all a Syncer problem. Actually, I think that's a great transition. I think we could move to the next topic, and I can, Laura, if you could go to the SIG notes agenda. Yes, this is the diagram. I'd like to get the SIG to see, and we can look at Bobby's topic. But here's what I think the SIG for this multi-cluster vision overall of ambient computing and multi-cluster deployments or multi-cluster workloads. All the topics that we can talk about. MCO is a scheduler, so it's one small brick, right? The cluster inventory is cluster profile. We've been discussing that a lot, and there's still some stuff, but it's a very important part of it. Then there's 2 things I think that you're talking about, Ryan, is like the multi-cluster packaging, which is more of the controller that would react like, okay, if there's 5 clusters, how do I place the workload? Do I template, or do I want progressive? That kind of logic, and then you could imagine for stateful and stateless could behave differently, and there could be a bunch of logic there. The Syncer is another thing. It's like the Syncer. I think today the only standard we have in SIG-MC is the work API, but there could be other implementation of that. I mean, Argo definitely has one with application. It takes a requirement. I mean, an app for one cluster, applies it to that cluster. Super simple, right? The Syncer job. And then on the right side, there's some networking. We have MCS there, but I think we could do more. And on the left side, we have the ergonomics, UI, UX, interface, proxy, whatever that ends up looking like. I think there needs to be investment on that. And we'll have to help give an interface for our multi-cluster so you can stay on that hub cluster and see the pods and see it potentially do exec, potentially do log forwarding. I think Kubernetes was widely successful because it has that interface. It's not just, oh, I'm going to put your job there and good luck. It also needs, right, to help you and stay on that single API. So those are, I think, all the bricks we should work on, and ideally we could work on them independently. But yeah, so for your question, I think the multi-cluster package and the Syncer are the 2 pieces that the scheduler integrates with, or I guess the scheduler just integrates with the multi-cluster package, and then the Syncer takes over. Anyway, so that's the picture. I hope it resonates with people. Let me know if it's too muddy.
Yeah, and also I would like to add that, for ourselves, let's set a deadline, because we have been slow, and I've brought this up in the past. I think that we need to make major progress in a few areas that I've listed above. Having auth in cluster profile so that the hub cluster can access other clusters, the workload clusters, with the information in the cluster profile. That part is currently missing. I think cluster profile does not have all the information needed for that cluster. That's one. The second thing, let's also create an API for placement strategy and policy among multiple clusters. And the third one is cluster auto provisioning. I know that Nick was saying that no customer is asking for it. It's pretty natural today, because today there are not great reasons for having cluster auto provisioning. For example, if you are chasing capacity in a cloud provider, there is no system that would automatically relocate your workload to a new cluster. But when such a system exists, and if the region has, let's say, GPUs, and you don't have any clusters there, you may actually want to create a cluster automatically there and move your workload there. So once something similar to MCO or a replacement for it that has the same functionality is available, then cluster auto provisioning becomes more important. So it takes us one step closer to a true, like, elastic ambient compute that we would like to move towards. So the third one is cluster auto provisioning. I put it optional because I think it's going to be really pushing it hard to get there by KubeCon, which is in November. But if we can achieve all the three, it's great. If we can achieve the first two, it's still good. Yeah, I just wanted to bring this up and see if SIG agrees.
I can give like an initial impression of me as Laura, which is I think that this orchestration has generally been like a like key issue for years, definitely from like its like original like implementation and attempts, and it's something that continues to be highly in demand. So I definitely think that as like in the jurisdiction of the SIG of trying to like address these problems, that's really important. I think this image and like this sort of like separation of concerns is like, I think has been like, some of it has been implicit for like people in upstream and also who are dealing with these problems, making this concrete that these are like the pieces and the pillars that we're talking about, and that like we're okay with, or that this jives with what everybody else's experience has been, or at least is like a workable framework for us to go forward to like talk about things, I think would be super beneficial, so that we can all be talking about the same thing. Because I think that's definitely something that we've been kind of like trapped, or it's difficult because everybody's coming with their own thing in their own situation. So I think I would highly encourage everybody who's on this call or following this later to like kind of think critically about your situation or your use cases, and what this diagram itself, just the diagram side itself, is like trying to convey about what the pieces are of this vision. And I think if we can like get unification kind of on that, that's already like a lot of the battle. As to like the prioritization of like these subsets of things and like the deadlines and the times, I'm definitely pro having auth and cluster profile. Honestly, I lost the thread of like how that, like where we kind of landed on that last. So I think we kind of need to like dig up like where we kind of got stuck, and like come up with a tactical way that we can like move to the next stage on that. I don't personally have like a super strong feeling about the other like steps of the prioritization, but again, I would encourage everybody who's on this call or elsewhere to add their thoughts about that. Yeah, that's kind of like my first blush take, and kind of putting that in what I think the context is, especially compared to, I think especially folks who have been like working on these prototypes, whether it's MCO or other in their organization, have whatever their version of this diagram is in their mind, right? And so, yeah, I think if we can at least get on the same page about this diagram and that we're all talking about the same thing, and then that's going to do so much for us. Ryan, I think your hand was next.
Just a high level observation from my side. Like this graph make sense? What I'm talking about that I think I don't know who probably quarantine putting this one, or Bob, I don't know who putting this one. That makes sense. The daunting part, I think there are two parts. One is just look at the graph. We know how many things we're missing. We're missing tons of them, and to make this work, and like the cluster inventory took us like 1 year, and we still don't have the credential part, which is very important. Credential and property, two things to me are must have for the cluster profile to actually be useful. So that took us already a year, and definitely it's a very aggressive agenda. What my question is, and the second thing is we already have a lot of, as Laura and someone else mentioned, that we already have a lot of offerings in the if this is like 5 years ago, and we are like everybody is putting on, probably I feel more optimistic now. The problem is we already have a lot of existing solutions out there, which all doing one variation of this. So this high level definitely works. Just everybody is doing a little bit differently. So I don't know how can we what type of a mechanism. So with these two problems, I'm just wondering what type of mechanism as a SIG we can kind of tie up all these things and speed up things. I don't have an answer for that. I definitely would be happy if we can get to this point. Just I don't know how can we get to this.
I think that first. Oh, sorry, I was going to say, I think that first we agree that there is a need for a placement CRD, and then we evaluate on whether MCO fits that need. It's as simple as that.
That's just schedule. We have so many other boxes to fill.
I guess I'll go first, and Bobby, you can complete. That's my goal by defining this diagram, is like showing all the boxes that we may want to look into and we may want to drive independently, and ideally we would have well-known interfaces there. A solution would have all those pieces and make a conscious choice of picking one for each of the solution. But I think as a SIG, we can encourage every single of those boxes to kind of like come up with one or more solution at least. And once we have all that, then someone can come and put it together as a solution, right? So it's like I've always been like there's the solution that picks one of those boxes and for each, and then the building blocks that we need to build independently, like they need to be built and they need to be interchangeable as much as possible. That's why I'm like, okay, scheduler, I can pick and stuff. And that's why for MCO as a solution, when we do the more orchestration, we picked Argo CD. That way we didn't have to re-implement that whole stack. And we're like, okay, well, we're going to integrate. So I'm hoping for the SIG now for development, right? We can look at all those boxes and have independent and hopefully offline work on developing the building block, and having either a reference implementation or having a bunch of examples and gather things and make sure as a SIG that we align everyone on the same interfaces on those blocks. That would be my hope, and moving forward on that. I have a suggestion somewhere that I need to share soon on like pillars on how we could also in the SIG have those pillars which are kind of representative of those boxes. Every time we go in the SIG, we go a little summary of how those topics are progressing independently. So we can spend 10 minutes on doing status on MCS, on the multi-cluster load balancing, effectively, on scheduling, on inventory, and on things like that, bam, bam, bam. And so also people could focus on one topic at a time, because our SIG is very dispersed otherwise. So if we could focus on one box, people focusing on one box at a time, I think people would specialize and provide better solutions there instead of seeing the whole thing every time. Anyway, Bobby, go for it.
So first of all, I just wanted to acknowledge what Brian mentioned. This is not 5 years ago. Today, there are a few solutions out there, and many of us have built our own solutions for this problem. And one of the reasons, actually, I am trying to push hard and put a close deadline, it's a tight deadline on this, is to reduce fragmentation. Because if we don't act now, things are going to get 10 times worse. Today, there are not a zillion customers that are using these platforms. Although these platforms exist, there are not a whole lot of customers who are using them. If we don't act now, there will be a lot of customers, and for them, it's going to be a lot harder to switch in the future. So what we can do as a SIG, and in fact, I think it's our duty to act now, come together with an open mind, willing to compromise, and get to a converged solution. Unlike Nick, MCO is my brainchild. But still, unlike him, I don't think MCO is necessarily the solution, but it could be one of the options. I actually don't know about that. We should come together, think about it, and see if we can get there and devise a single solution to reduce fragmentation in the market. That's my goal.
I'm going to interrupt here so we can give some more time to the last agenda items. But again, take this food for thought. Let's talk some more about it on Slack. I'm sure we're going to be talking about it at other meetings as well. Again, if this sort of priority list and even just like architecturally way of thinking of this problem resonates with you, if the problem itself resonates with you, that's something that I think everybody here, and especially the proponents of this agenda item, are really looking for some feedback on, so we can unify around this if we think this is what's most important. Ryan, you have the next agenda item.
So that one should be quick because that basically, if we can, yeah, thank you. That's basically we discussed last week, right? So we can separate out that ladder into about API. So that's exactly what I did. So now it's in the about API. I reworded the process a little bit and fixed some of the the view and other one confusion there. So yeah, because I only made it like yesterday, so I don't expect anyone has really reviewed it, but just hopefully you can take a look at we can discuss more details in the next meeting.
Okay, awesome. Yeah, feel good about this, and yeah, I do want to talk about more details, but let's do this offline first. And thank you for separating it out so it's easier for us to kind of address this separately from the rest of things. Cool. And then Ryan and Arthur.
Yeah, just Arthur is also maybe you can just so I think this one Arthur told me that it's ready to review, and this one has been being stuck there for a while. I think it's time to, and we have another engineer from Microsoft is also trying to help. So I think we now have enough resources to push this forward.
Okay,
and Arthur is here, I think.
But just can we, well, I don't know if we have time, but can we re-talk a bit about the like why we are moving out of the spec, the field? Because I kind of understand the status move that we wanted originally to make, but moving out of the spec, I'm not sure, like, is it written somewhere that this is an actual best practice and that we should do it? Because
Okay, I hear you. I don't know if Mike is in here too to talk about it, but the track back of the history of this conversation kind of starts here, and then continues in like lots of chatter in this PR, and then, as you know, like this is here. So there may be something here to like encapsulate at least like this heritage into some single doc or something that's like more closely associated with like the code change. Fundamentally, the idea is the difference between this being something that's user specified or something that is system specified. And Mike, I see that you are alive and well here, and you can also give some more history.
Yeah, I think that you're also asking, Arthur, specifically there was like one person who left a comment basically asking like, why are we doing this? And I can take an action item to follow up on that today to kind of like summarize some of this background context. And also it seemed like there were some concerns about like a conversion webhook and such. My understanding and expectation from this work is that because service import is a resource which is typically written by a machine controller and not a human, that we would not need a conversion webhook of any sort. It would just be logic in the implementation to update how it is writing it.
Oh no, but we kind of do. Like it's written by the implementation, so it will be auto updated. But for instance, like the core DNS plugin reads service import, so it would totally be broke for a few minutes at least, or maybe more, even if you have a ton of service import.
If you have the details on the core DNS implementation, let's start a Slack thread on that, because I have not looked at that very closely.
But yeah, basically the TLDR is that we need a conversion webhook even if it's not user writable. But can you because okay, status change, the origin of this I fully understand, but like about spec, do you have some reference that points that machine generated CR should not be in spec or something?
I think there is a reference in the API style guide for Kubernetes.
Yeah.
I will find the reference for you.
Awesome.
Okay.
Okay, so it sounds like there's going to be a little bit of a thread conversation about this, but yes, heard, seen, good connection point, everybody, on the V1 Alpha 2. Okay, any other comments on this or the last? Yes, Ryan, what's up?
Yes, unrelated. I realized that it looks like we don't have any recordings for the last few months. Because someone asked me whether there's recordings so they can watch the meeting. Is the channel that I see don't have any updates for
All
the
right,
last few months.
let's all beat up Jeremy. Ready? 1, 2, 3, kick him.
Yes, I'll spend some time catching up this week. My bad.
Is there any way we can automate it so that it doesn't require manual work for you?
I think there is recently a tool. It is a little painful. We'll follow up there and see what the progress is. I know there was something that was being tried out.
Thank you very much.
Cool. All right. Good meeting, everybody. Let's meet again next week. And otherwise, it sounds like we're following up on Slack on at least V1 Alpha 2, and then more generally, possibly about any other comments about the MCO demo, and then more importantly, of how that kind of maybe filters into this larger vision about what work the SIG may want to collaborate on more pointedly for the coming months. Thanks for coming through.
Bye-bye.
Bye.
Bye.
Thank you.
Bye-bye.
Bye-bye.
Thanks. Bye.